Welcome to this video. We're going to cover the fetch sequence. Now, the first thing that you need to understand is the naming of these switches right here. The switches are named based on the intent or the action that happens when we turn on the switch. So for example, PC to bus 1 takes the value of whatever's in our PC counter and puts it onto bus 1. So if we put something in our PC counter, and make sure our reset is off so that the register can work. So we put the number 5 in our PC counter. When I enable this switch or turn it on, now remember it's low asserted, so that means on is a 0 voltage, then that takes the value and puts it onto this bus. Now you can see we're getting a conflict because that happened to be on and that one happened to be on as well. But now when this is the only switch that's on, our PC counter is now onto bus 1. And just to describe that, the conflicts right here, if I put the input device onto bus 1 as well, now the input device is saying this wire should be 0, but the PC counter is saying that this wire should be a 1, and that's where the error is coming from, because one is trying to drive a wire high and the other one is trying to drive it low. So whenever you get red in your circuit, make sure that you only have one thing connected to the bus at a time, or else you'll get those conflicts. But here's our PC to bus 1. So those switches, usually anything to bus 1 or to bus 2, is going to be a switch that enables a tri-state buffer. Now we have these switches over here like bus 3 to PC and bus 3 to MAR. Those switches are the clocks on the register. So if we go down to our ALU and we turn on TRA1, for example, and now you can see we have 5 on bus 3. So this wire down here connects to my ALU and happens to be bus 3. So we have the 5 coming out onto bus 3. And when I take this register from a low voltage to a high voltage, it takes the 5 from bus 3 and puts it into the register right here. So bus 3 to MAR says take the value on bus 3 and put it into the register. So bus 3 to anything is always going to be a clock on the register. Now remember that that clock gets activated on the rising edge. So when we have a low voltage that goes to a high voltage. For example, if we put something else in our PC like 7, and now 7 is getting passed through our ALU onto bus 3, and then when I click this switch, from a low voltage to a high voltage, the 7 gets put into the register. And often I'll say clocked into the register. Now there are, this switch right here might be the most confusing switch of all, because we have this register take bus 3 and put it into the memory buffer register. So when I do that, that's what happens. Now if I go here and edit the contents of my memory, and that's memory location 7. So 0, 1, 2, 3, 4, 5, 6, 7. And I'll put dead here. Now you can see we have dead coming out. So MEM to MBR is the switch that says, why don't you select the memory output to our MUX instead of bus 3. But we still this switch here is kind of misnamed because it says bus 3 to MBR, but when we flip this switch, it's no longer bus 3 going to MBR, it's the contents of memory going into MBR. So again, when we clock that switch, then the word, the dead coming out of memory gets clocked into that register. All right, so we have these switches, and again, these are the tri-state buffers. Whenever you connect to bus 1 or bus 2, those are going to be tri-state buffers. So this one is called PC to bus 1, or MBR to bus 1, input to bus 1, the number 1 to bus 2, and then we got GPR 3 to bus 1, GPR 3 to bus 2, and so on for the rest of those. Target to bus 1, upper immediate to bus 1, unsigned immediate to bus 1, and signed immediate to bus 1. And those are all switches on our tri-state buffer that connect these registers to the buses. Then we have the switches that point into our registers. And those are all clocks on a register. Now, in this case right here, in this case right here, where we have two arrows that point into our register, that means we have two inputs. So that means we're going to need a mux for it. Now, I already showed you the mux, that's just the push button, and you should have all that working. But the mux, the switch on the mux down here, like I already showed you earlier, is called memory to memory buffer register, and that just switches the mux so this becomes the input instead of that one. And then the clock on the MBR is called bus 3 to MBR. So those are the names of all the switches. So now we're going to learn how our computer is going to work. So imagine we have some instructions loaded up into memory. And the first instruction starts at memory location 0. And we have our program counter, and we point it to location 0 as well. So the idea is we take our program counter. Now you'll see why this is called a data path, because data is going to be flowing through this path here. We're going to take our program counter, put it onto bus 1, turn on TRA1 to take the program counter onto bus 3. But the only thing that we're going to clock it into is the MBR. So we clock the program counter into the MBR, and that causes 0 to go to MBR. Now memory will be looking up whatever's at memory location 0 and spit out its data, which we hope is an instruction, out here. So now step 2, we're going to switch our mux so that it selects the input from this one and not that one. And we're going to clock this MBR. But at this time, we would like to increment our program counter because if you notice, our ALU is not being used. So at the same time, we're going to leave our program counter onto bus 1. We're going to take this number 1 and put it onto bus 1 as well. And then we're going to turn on add on our ALU. Now the add will add our program counter plus 1, so we'll get the result of that. And then we'll flip our switch bus 3 to PC, which will take our program counter plus 1 and clock it into here. So then we'll have 001 in our PC area. So we'll be doing that at the same time that memory is loading the instruction into the MBR. Now the next step of the fetch sequence is to take the instruction that just came out of memory, pass it through the ALU, so that's going to be the TRA1, going to pass that instruction through the ALU up, and then we're going to clock it into our instruction register. Now that we have an instruction in the instruction register, we can look at the opcode, figure out what kind of instruction it is, turn on the switches here and here to be able to cause that instruction to happen and maybe update something. And then we're going to go back to the first step and get the first step. So there's really 4 steps. 1 is to get the program counter into the memory address register. Then the second step will be to get the instruction into the memory buffer register. And while we're doing that, we might as well add 1 to the PC. Then the third step is to get the instruction from the memory buffer register into the instruction register. The fourth step will be called the decode, where we'll look at the instruction we got out and figure out what it is. And then the fifth step will be able to execute that instruction. And then we'll go back to the first step and do it over and over again until we're told to halt. So here are these 5 steps right here. So what switches do we need to turn on for each step? Step 1, we want to take our PC, pass it through the ALU, and put it in the MAR. So those switches are PC to bus 1, TRA1, bus 3 to MAR. Now step 2 is to take what's in memory and put it in the memory buffer register. Now those switches are MEM to MBR, and remember that's the mux that's going to shut off that one, and select that input to the MBR. And then bus 3 to MBR is the clock on the register of the MBR. Now, while the memory is busy doing that, we're going to use the ALU to add 1 to our PC. So the next time we fetch an instruction out of memory, it'll come from the next location in memory. So the switches that cause that to happen is to make sure the PC is on bus 1, turn on the 1 to the bus 2, turn on add on our ALU, and then take bus 3 and clock it into our PC counter. Now the last step, or the last step of the fetch before we start decoding the instruction, is to get the instruction out of the MBR and up into the IR. So those switches are MBR to bus 1, TRA1 to pass bus 1 onto bus 3, and then bus 3 to IR, which is the clock that clocks the data from bus 3 into our instruction register. Now that the instruction is in the IR register, we can decode it by looking at the opcode, and if there is, also look at the function code. Now, after we've decoded, the next step is to execute it. Now let's say that instruction happens to be an add instruction that adds register 1 and register 2 together and stores the result in register 0. So what switches would we turn on for that to happen? Well, we turned on register 1 to bus 1, so register 1 will connect here onto bus 1. Then register 2, our other input, will connect onto bus 2. And then we'll turn on add on our ALU. And then finally, we'll take the result and clock it into register 0. So those are the switches to execute the instruction. After we've executed the instruction, we go back and we start again. And since we've added 1 to our PC counter already, we'll fetch instruction number 2 out and we'll do the same cycle all over again. So that's the fetch sequence. So now you could go back to the datapath video, and as it shows you to pass off, you're going to simulate this fetch sequence, at least up until this point right here, to make sure that you can get an instruction out of memory and into our instruction register.